Hi, good day to Dr. Haffidzudin. I am MEHGALAA RAVICHANDRAN from Group 3. Today I am going to present about our CNC and CADCAM project report on milling and lathe. My group members are GHUGAN Analalaki Sundramurthy, Elijah Analalaki Barnabas, and Ahmad Zahin bin ZAINAL RASID. Now I am going to explain about the background of project for lathe machine. Computer-aided design (CAD) and computer-aided manufacturing (CAM) are combined in CAD/CAM. CAM is based on computer numerical control (CNC), in which production equipment and tools are moved according to pre-programmed computer software. Students will get the skills to load instructions into the lathe in a machine-readable format, convert instructions into criteria for tool selection, install tools and components for handling the material, and create sample parts in CNC lathe lessons. Besides, CNC lathe training often includes using the lathe itself as well as making modifications to the machine, modifying programs, and creating new command syntax. There are three main objectives on why we are doing this lathe machine report. The first objective is to use all the knowledge learned during the practical session to redesign the product using MasterCam. The second objective is use animation techniques to validate the machining procedures. The third one is produce the G code for the NC codes. For the scope, there are two scopes on this report. The first one is the program MasterCam is used to create drawings, animations, and G code only. The second one is CNC machines are operated using a language called G code. Producing completed pieces out of raw materials is one of the CNC lathe machine's primary tasks. Metals, polymers, and wood may all be utilized with the machine to cut, drill, bore, and shape them. Actually, there are many types of CNC lathe machines, but we are just focusing on two of them. One of them is horizontal CNC lathe and another one is vertical CNC lathe. The first table shows the examples of G code and N codes. Okay, if we see randomly, G00 is used to rapid motion positioning, M05 is used to stop spindle, and G04 is used to dwell, and M06 is used to tool change, M08 used to flute coolant on, and M09 is used to coolant off. Okay, well, the table below shows the advantages and disadvantages of CNC lathe machines. Some of the advantages are it has high precision and accuracy, it can increase productivity, it is more versatile, and then it have more consistent. Besides then, it is also fully automated. Okay, for the disadvantages part, the lathe machine have high initial cost, then it requires skilled operators, it is also have limited flexibility only, then the maintenance and repair, it is more costly a bit. Okay, then it is also more complexity. Now I am going to explain about the CAD/CAM operations in CNC lathe machines. The first step is a 2D vector or 3D solid part design created using CAD software is translated into a set of instructions for the CNC machine using CAM software. Secondly, all machining operations such as turning, boring, and drilling are organized by CAM software, which also creates the tool path that the CNC machine will use. Thirdly, an operator sets up the CNC machine, inserting the workpiece and the cutting tool before starting the program. Then, the CNC machine runs the program, which specifies the pace and location of machine tool operations in advance and carries them out at regular intervals. Then, during the machining process, the operator may also make changes to the program, such as altering the CNC programming or producing several cycles of test components to improve the outcomes of modification. Finally, CNC machines may function independently via CAD/CAM integration, which boosts productivity and expands manufacturing capacity. Now I am going to explain about the very basic CNC lathe machine procedures. The first step is machine setup. The second step is CNC program loading. The third step is set the workpiece on the machine. The fourth step is measure and establish the tool offsets. After that, machine start an operation. After we cut the workpiece, remove the chips and coolant. Then stop the machine and we can proceed on the post processing. Apart from that, tools and equipment that attach on the CNC lathe machines such as turning tool, boring tool, facing tool, chamfering tool, knurling tool, arching tool, boring bar holder, drill chucks, coolant tanks, chip pans, chucks, faceplates and mandrels. There are some best workpiece material that used on CNC lathe machine. The first one is metal, including aluminium, copper and steel. The second one is plastic, including nylon, PVC. The third one is wood. Both hardwood and softwood may be machined using CNC lathe equipment. Apart from that, safety procedure for CNC lathe machine is also very important, such as observe guidelines, safety glass, ear protection from noise, glove, safety shoes, and then keep workspace neat, keep your attention, familiarize with machines, and then proper shutdown is very important.
Greetings. My name is GHUGAN son of SUNDRAMURTHY with the metric number of CN200015. Here we'll be continuing on the late presentation, and here you can see the result of the tool part, which includes the face, roughing, finishing and drilling tool parts. Here on the first two pictures on the top left, we can see the image of face milling. On the two of the right side of the picture, we can see the roughing face. And two pictures on the left below, we can see the finishing part, and the right side of corner down is the drilling part. And now we will continue on the result for the lathe. This is the NC coding in Notepad. And now we'll be looking at the discussion for the lathe. MasterCam is a good at creating toolpath and NC codes for machining purposes. However, this can be different in a reality where the machining process still can be influenced by other factors such as vibration, materials properties, and machine system to synchronize with the codes posted. To specify the necessary geometry, users can draw lines, arcs, circles, rectangles, polygons, and other forms. To improve and change the design, these tools additionally offer choices for filleting, chamfering, trimming, and extending entities. CAD or CAM software revolutionizes contemporary machining by revolutionizing part creation and becoming essential for CNC lathe operators. And now, let us continue with the conclusion for the lathe. CAD or CAM technology and CNC lathe have revolutionized the industrial sector by facilitating accurate and effective machining processes. Numerous benefits, including automation, repeatability, and flexibility, are provided by CNC lathe machines, enabling the highly accurate and reliable manufacturing of complicated parts. Many manual tasks are eliminated when CNC lathe machines are used, reducing human error and raising overall productivity. CNC lathes have become essential in a number of industries, including aerospace, automotive, medical, and electronics. Future innovations in this technology will improve manufacturing capacities and provide constantly more creative and accurate goods. And now let us look into the recommendations for the lathe. CAD or CAM system and CNC lathe may both be significantly improved by technology improvement. Incorporating intelligent technology may also assist, avoid unplanned downtime, and maximize equipment utilization. Examples include real-time monitoring and predictive maintenance. Fully utilize CNC lathe and CAD or CAM technologies. Operators must receive through training. The proper operation, programming, and troubleshooting of machine should be thoroughly taught to operators.
Assalamualaikum and hi, my name is Ahmad Zahin my nick number is CN200172. Today I will present about the background of a project of milling machine. CNC machining is a sophisticated manufacturing process that uses pre-programmed software to control production equipment. CAD software is used to define part dimensions which are then translated into manufacturing instructions with CAM software. This project focuses on milling machine, which remove material from a workpiece using a rotation cutter. Increasing the number of teeth on the cutter improve material removal rate, efficiency, and productivity. Skills, CNC machining, and programmer are essential for the optimized performance in the industry. For the objective of this milling machine is to create the product based on milling machine using MasterCam, with using all the knowledge gained throughout the tutorial season. To verify the machining process for animation method in MasterCam, generate the NC code, which is G code. For the scope, MasterCam software is used for making drawing animation and generate G code. G code is a language used to control the CNC milling machine. This is for the detailed review. Function of CNC milling machine is a CNC milling machine use computer control and CAD file to shape workpiece with exceptional precise and finishing. There are two common CNC milling machine. For the blue one is a vertical milling machine, and for the green one is a horizontal milling machine. Next, for the CNC machining programming, there are two, G code and N code. For the example of G code is a G00, rapid motion positioning. G01 is linear interpolation motion. For the N code is for the example is M02 is the end of program. For the M03 is a start spindle for the clockwise. There are advantage and disadvantage for CNC milling machine. For the advantage, CNC milling machine is the precision and accuracy, automation and unattended operation, versatility in performing various machining operations. For the advantage is a high initial investment cost, complex in the operation and programming. Next is methodology milling machine. CADCAM operation in CNC milling machine. CADCAM software enable precise design creation with customizable feature. Second is CAM programming generate machine instruction for CNC milling machine. To pass, generate optimized tool movement for desired part shape. Simulation and verification ensure safe and error-free operation. Post-process convert to pass into machine specific code. Machine setup involve install tools, secure the workpiece and loading the program. Machining execution remove material based on the program instruction. And iterate optimize allow for the adjustment and rerunning the program. Data management feature streamline storage and retrieval of the design file and parameters. Next, CNC milling machine procedure. Machine setup, workpiece and tool measurement, CNC program loading. Next, machine warming up and homing. Next, tool length compensation, dry run and simulation, machine setup, machine start and operation, machining completion, post-machining task, machining maintenance. For the tool and equipment for the CNC milling machine, cutting tool, tool holder, work holding device, probing system, cooling system, chip management tools, control panel and software, and lastly, safety equipment. Next, for the methodology milling is a workpiece material for the CNC milling machine, such as metal, plastic, composite, wood, and other material. Safety procedure for the CNC milling machine, operator training, personal protective equipment (PPE), mission area safety, emergency stop, cooling safety, workpiece, and work holding safety, machine setup and maintenance, chip management, spindle and tool change, regular inspection and risk assessment. Now I would like to pass the slide for my friend Elijah. Thank you.
Hi, my name is Elijah Barnabas, and this is the result of milling CNC milling tool parts. Okay, the tool part for the first is slot milling, which is used 6 mm diameter end mill, and then circle mill. The circle mill is used 14 mm end mill flat end mill. So the third step is 2D high speed dynamic mill, which is used 12 mm diameter end mill flat. And the fourth and the last for setup one, which is contour 2D, which is also used 12 diameter of end mill. And then the setup 2, starting of the setup 2, which is the first tool path is for setup 2 is facing. So the facing mill is used 50 diameter of face mill. Okay, this slide is about the simulation of the CNC milling. First, the slot mill. and the second is circle mill, and the third is 2D dynamic mill, and the fourth contour 2D, and the last but not least face mill, the profile. Okay, this slide is about the NC coding, which shows the coding of the simulation process. And now the discussion for CNC milling. CADCAM software enables precise design creation and toolpath generation for CNC milling machine. And secondly, simulation and verification help identify and resolve potential issues in machining operation. Machining parameters such as tool selection, dimension, and cutting parameters are determined based on the part drawing. Then CADCAM software allows for iterative optimization of toolpaths and cutting strategies for improved efficiency and accuracy. Visual simulation and animation provide a realistic preview of the machining process, helping to ensure error-free operation. Lastly, proper setup and organization of toolpaths and files are essential for efficient and organized milling operation. Conclusion for CNC milling. CNC machining with CADCAM software revolutionized manufacturing by producing high-quality parts with CNC milling machines. CADCAM software enables precise geometric design, optimized tool parts, and programming instruction. Simulation and animation ensure accurate and error-free machining operations. CNC machinists expertise in CAD/CAM software is crucial for optimal performance and quality component production. Integration of CAD/CAM software improves precision, efficiency, and productivity in milling operation. CNC machining with CAD/CAM software drives innovations and advancement in industry like aerospace and automotive, and so on. Recommendation for CNC milling. Invest in training and skill development for CNC machinists and programs to maximize their expertise in operating CNC machine and utilizing CAD/CAM software. Continuously review and optimize CNC machining process to improve cycle time, surface finish, and productivity. Implement robust quality control measure to ensure dimensional accuracy and adherence to specification. Establish clear documentation and standardized procedures for CNC machining operations. Regularly maintain and calibrate CNC machines to ensure optimal performance and accuracy. Lastly, foster a culture of continuous improvement within the CNC machining team to encourage feedback and process enhancement. That's all from us, and thank you for watching this video.